vectors, example 13. Vectors in 3D can also be described in terms of 3 unit vectors. Now remember, unit vectors are a portion of the size that has a magnitude or a vector of magnitude 1 unit. Okay? So we can say that I has a magnitude of 1 and it has the components 1, 0, 0. That means it lies on the x-axis. J has a component 0, 1, 0, lies on the y-axis. And K has a component 0, 0, 1, lies on the z-axis. Okay? So, I, J, K, X, Y, Z, alphabetical order. Or alphabetical order. Struggle with that word my whole life. So, I missed the purple pen. What that is this is the X's, this is the Y's, this is the Z's. Okay? You have to write them in alphabetical order in order to extract the components. So it says express vector U plus V. So U is 3i plus 2j minus 6k. The coefficients of each of the letters represents the components. So that means that U has the components 3, 2, minus 6. V has the components, now minus I means minus 1. Then it's 5j, and there's no k on there, so there's 0k. Okay, hey. So it's minus 1, 5, and 0 for vector V. You need to watch out. Sometimes they're not in alphabetical order. You must put it in I, J, K. Okay? So we're doing U plus V. That becomes 3, 2, minus 6, plus minus 1, 5, 0, which is 2, 7, minus 6. And that's U plus V. Now, the magnitude of U plus V, remember what the wee lines mean magnitude? So the magnitude of U plus V, we've just worked out what U plus V is. So it becomes 2 squared plus 7 squared plus 6 squared. I ignore my negatives when I'm squaring and square rooting, because you don't need it when you square it. Gives me, root 89. I'm not even working that out. I'm letting the calculator do the work for me. Okay? Now, scalar product. Example 14. Angle form. You are given this in the exam. Okay, you're given the formula. The scalar product is the result of a type of multiplication of two vectors to give a scalar quantity, i.e. a number with no directional component. So we're not doing a vector. For vectors A and B, the scalar product, also known as the dot product, not many people call it that anymore, is given as A dot B, that's how we say it, okay? A dot B, hence why it's called the dot product, because a dot at the bottom means multiply. A dot B equals the magnitude of A times the magnitude of B cos theta, where theta is the angle between, and the vectors have to be pointing away from the corner. Okay, so I do it as if this is my wee head, right? And then it has to be my hands. How many fingers do you have? Pointing away. Okay, that's how I do it. And yes, I have just realised. 1, 2, 3, 4, 5. Right, that's how I do it. You're pointing away. Normally, if you could see me, this would make sense. Okay, so vectors must be pointing away. So are my hands down here? Yes, they are. Are my hands down here? Yes, they are. No, my hand's down here and one's up here. So I'm not pointing away. So we need to watch when we get to C. Okay? The wee bumps are hands. I'm now not trying to draw, because you'll just take the mickey out of me. So, where magnitude of A is 6 and magnitude of B is 10, find the scalar product for each one. So on A, we are A dot B equals magnitude of A, magnitude of B, cos theta. That's a theta, honest. So my magnitude of A was 6, times my magnitude of B, which was 10, times cos of 35. Now, please make sure your calculator is in degrees when you're doing this. You type it in and it gives you 49.15. That's it. All you're looking for is a scalar, which is just a number, no direction to it, no component, nothing. Okay? On B, don't know what's happened. On B, we are the same. A dot B equals magnitude of A, magnitude of B, cos theta. Ooh, better theta this time. So we are 6 times 10 times cos 103. Now, if you're working out an obtuse angle for cosine, it's going to be a negative. Because of your cast diagram, that's still in play. So this time, it's going to give you negative 13.5. Please note that my decimals are written in the middle of my digits. My dot product written at the bottom of the A and the B. Okay? Now, some people spot this straight away, some people are like, what? But vectors are movable. See, as long as I don't change the arrow, in this case, and if I don't change its length, it's still the same vector. So what I can say is, because these are not pointing away, I need to move where my hands are. So what I can do is, that's a squinty line, I can do A down here and make that my wee head. Okay? That makes that a straight line. And straight lines add up to 180. So that means that in here becomes 140. So to work out A dot B, I'm still magnitude of A, magnitude of B. Do not know what's happening with my writing today. Cos theta. So a magnitude of A is 6 times 10 times cos 140 will give me negative 46. And it works out because of that cast diagram. Okay, and the fact that you can move vectors. As long as you don't change the direction. We wanted that arrow to be pointing away from one another. My hands weren't. So I could move that vector down.